Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today we're talking about interstellar travel. Hey Ben, how are you?
Hey Simon, hello fellow Econauts. Yeah, today we want to talk about leaving our solar system.
Leaving our solar system. And that is exactly what the first question is about. What exactly is interstellar travel?
I mean, I gave it away already. My
A
apologies for
little
that.
bit, yes, a
But
little
yeah,
bit.
so we have interplanetary level travel, which means leaving Earth, going to another planet. And interstellar means stellar is stands for star, means between stars. So we leave our solar system and go to another star system. That means interstellar travel. Very, very simple.
And what would be the closest system to our system?
So the closest system we have is Alpha Centauri. I think that's 1.3 parsec, which is 4.6 light years distant. So light needs 4.6 years to reach our solar system.
And how would we get there?
Well, currently we can't. We have currently not the technology to we have the technology to leave the solar system, Voyager 1 and Voyager 2. Just reminding our viewers that we have an episode about that. They have left the solar system, but we haven't been farther than that. And it took them 70 years just to leave the solar system. So we are very, very far off reaching even near the speed of light. And even if we were able to travel with the speed of light, then it would, as I just said, still take us 4.6 years to reach that star system. Also, because of Voyager 1 and 2, we know now that outside of the solar system bubble, there's actually more particles floating in space than we thought before. And even if that wouldn't be the case, there will be always here and there small dust particle and meteoroids and other things in the way, even small ones, small particles, atom size. If you travel with the speed of light and you hit one of those things, they penetrate your spacecraft. So we also need to develop a form of a shield. Might be either a shield traveled in front of the spacecraft in terms of maybe something with water in there which can actually decelerate particles quite well, or an energy shield. So and then we can spin this idea further and further. Where do we get the energy for that from? And how do we refuel that? How long is the energy available? And so on and so on. So there's many problems we have. And yeah, so even with the solar sail, it's not possible, because in the moment you leave the solar system, you don't have enough photonic pressure anymore to travel further. And although you have nothing to decelerate you, I just mentioned there is a small there's an amount of particles there. Eventually the friction would be enough to decelerate you enough so you wouldn't move anymore.
So from my perspective, we have a couple options here, and I'm just, of course, if I say a couple options, I'm not saying like we have them available right now, but to have like a theory how we could actually get to the closest system. So let's imagine we would be able to travel with the speed of light, then it would take like 4.6 years to get there. The next option would be actually having a warp drive. That would be the other option. And I think the third option would be a generation ship. So a ship that would be able to travel at the same speed like Voyager 1 and 2. And then it would take like forever to actually
Hey,
get there.
forever. Yes, pretty much forever. I think if we were to build such a ship, there would be thousands of generations. With all the problems we have, even going to Mars, we don't have enough. And we talked about this, I guess, as well. We need the right nutritions, and we have to grow something in space, and so on. We have to recycle all the waste, and I mean all the waste. So we have to get our head around that. But you could even argue that, like, after 1,000 generations, is that still a human reaching that star system, because then the evolution might have kicked in and it might be a complete different species by then. But yeah, let's focus on the warp drive. I think, interestingly, although it's obviously a complete science fiction construct from the Star Trek universe, there are actually theories, physical theories out there proposing that this is a possible solution. And with warp, you could actually travel faster than the speed of light. And obviously, we're talking about for Alpha Centauri, which is like 4.6 years away, maybe 4.8. Again, don't quote me exactly on the number, but that's the order of magnitude. It's 4 trillion kilometers distant. But even 4 years is a lot of time, and that's the closest one. If we want to reach any other system, then we need more years. We need decades, even with the speed of light. So we need something faster than the speed of light. Why do we need that? I think that's the other question. Eventually, and that will not happen in millions of years, eventually our star will die. That will happen at some point. So in order to survive, similar to the proposal of Elon Musk to go to Mars, because something could happen to Earth and then our species would be eradicated. That's why we need to become interplanetary. Humanity, in order to survive forever-ish, needs to become interstellar. There's actually another option which you haven't mentioned. That is, I forgot the name for it. It's a construct around
Teleportation.
no, not teleportation. It's again, it's only traveling with the speed of light.
Yeah.
So and there's a construct. Sorry, I have to Google very quickly because it's a well-known construct
Are you
in.
talking about bending the time-space continuum?
No, that is more or less what the warp
That's
drive
yeah,
is.
exactly. I was thinking that it's basically how warp drives are supposed to work. Everything is like
Dyson Sphere.
theory, right? It's not.
Yeah.
It's not.
So now what I was getting at is called a Dyson Sphere. A Dyson
Yes.
Sphere is a
Yeah.
construct around our star which captures all the energy. So you can imagine, because the planets, the light emits in every direction, so it actually doesn't reach all planets at the same time. So we could build, theoretically, it's also, building that would require a way higher advanced civilization than we are. Compared to them, we are still little amoebias. Anyway, if we would build a Dyson Sphere, we could also build a construct around the Dyson Sphere, moving the star. If we would move the star, all the planets would follow. So we could also build a starship out of our solar system, and that would be a perfect generation ship, because then we could still live. We wouldn't really feel the difference, and we could move our solar system close enough to another star system to then move over, building another Dyson Sphere over hundreds and thousands of years, and so on. So this would be another theoretical way we could do that. But sticking with a warp drive, if we were able to bend space-time with a warp drive, it would theoretically be possible to travel faster than the speed of light. And that is important to do space travel and interstellar travel, because the farther away you go from our solar system, so the further away the star is you want to reach, the faster that star system is moving away from us. So it's not only, it's not a fixed position. Everything is moving away from us. The universe is expanding. So therefore we chase after these parts, right? And the funny part is the universe is expanding faster than the speed of light. I think the whole interstellar travel is a very frustrating topic for people interested in space, because it means not only is it unlikely, especially not with our technology nowadays, to reach other stars, it is even more unlikely to reach further away stars. And it is possible that the furthest away stars don't exist anymore. And we can't even tell, because the information we receive here, most of the stars you see in the night sky, there are other star systems. They might be so far away that they have already exploded, but we wouldn't notice that for the next 100 million years, because that's how far they are away. You get the point.
Yes, of course.
So
Yeah.
even if we travel there, we might not even reach there, because there is nothing to reach. So yeah, so the universe from all the stars, I think there's a calculation somewhere. All the stars we see, there's like most of them are actually dead already and not existent anymore, and we just see the aftermath, more or less their image in the night sky.
I think one factor that you haven't mentioned, why we should become an interstellar species, is also the urge of exploration, something that we
Yeah,
have talked
absolutely.
about in other episodes before, and that is a very very large part of humanity. That's something that is defining us. We have always been explorers from basically the beginning of humankind.
Yes,
We always were curious. What is, you know,
the grass was always greener at the
always good.
neighbor's place.
What is beyond the horizon, right? We
Yes,
always wanted to
exactly.
know what is going on the other side. All right. I think we keep it for today. Otherwise, we will go and
We
start
keep it light, travel.
light travel speed, light speed of light travel. If you like this episode, please don't forget to leave a like, not a light.
Keep it light.
Keep it light, a light like, and subscribe if you haven't already.
And don't forget to hit that notification bell. And also, we have other episodes, so we would really welcome you to watch those as well.
Exactly, and always appreciate it if you leave a comment. All right, have a good one. Bye bye.
Bye.